Okay, this is lesson 5, and let's just jump right into it. So I'm going to start by drawing my methyl cyclohexane. So that's my 6-member ring with a methyl attached, and I want the most stable. So I think I'm going to add a double bond right over here. Add my hydrogens and hit arrange and fit. This is my end product. Let's see if that's right. Okay, my least stable hexane, so I'm going to draw my 6 carbons. 1, 2, 3, 4, 5, 6. And then for the least stable, so mostly for the most stable, it's going to be like keeping the symmetry. So for this one, I'm just going to add the double bond at the end to break up that symmetry. And 1, 2, 3, 4, 5, 6. Let's see if that's right. Okay. Okay, I'll start by drawing my pentane. Add my methyl at the 2 position. And now I'm gonna see how I can get the most stable. So I think what I'm going to do I don't think I have any notes on this. Let's see, I'm gonna add a double bond in the center and see what that looks like once I add my hydrogens. Let's try it out. Awesome. Least stable dimethylbutane, so 4, and then I have a 2 and a 3, 2 methyls. And then I'm looking for the least stable. So if I add my double bond here, it'll be the same thing on each side. So I'm going to try to add my double bond at the end, add my hydrogens and hit arrange. Let's see, I'm gonna undo it. It just doesn't look right to me. Because if I add it here, add my hydrogens, this is actually pretty stable. So yeah, maybe it was right. I'll do a double bond at the end, and I'll submit it and see if that was correct. Sorry, this is my second time doing it, so I'm going slow because I'm still kind of working things out through here. Least stable 3-methylpentene, so I'm going to do my 5 carbons, add my methyl at the 3 position, and I want the least stable, so I'm going to break up that symmetry and I'm going to add the double bond at one of the ends. Add my hydrogens, and I think that'll be good to go. Hopefully. Okay. Least stable hex 2 in. I'm going to draw my hexene. 1, 2, 3, 4, 5, 6. I have a double bond at the 2 going to 3. And least stable, so I'm going to want this actually on the other side. And then I'm going to add these hydrogens on the double bond manually so I can make sure they stay on the same side as each other. Okay, as we can see, this is a Z conformation because when we split this in half, the highest priority on this side is on the bottom, and the highest priority on this side is on the bottom. So this is the least stable because it's actually sterically hindered because they're both kind of too close to each other. The most stable would be these two switch, the hydrogen and then this one over here. So let's see if that is correct. Least stable, methylpentane, 2 position. Okay, least stable, so if I add it here, I might just add it at the end and see if that works out. 1, 2, 3, 4, 5. Let's go for it. Awesome. Okay, most stable, dimethylbutane, so like that, and then I have 2 methyls on this side. And for the most part, we usually try to keep it symmetric, but there's 3 here, so if I was to add a double bond here and add my hydrogens, it just doesn't. Look at this carbon, it's got 5 bonds, so that just can't happen. It doesn't work. So I will add my bond to the end over here, add my hydrogens, hit arrange and fit, and I think I have the right amount, and let's check it out. Most stable X2-ene. So I got my 6 carbons, and I have my double bond going from the 2 position to the 3 position. I'm going to draw the most stable, so I don't want any steric hindrance, so I'm going to keep the one with the highest priority on this side on the top, and then it'll be easier if I roll it around like this. I'm going to keep it on the top and keep this one opposite. So on the bottom, that means a hydrogen will go here and a hydrogen will go here for an E conformation, and that'll be the most stable. Alright, just like that. Okay, 2-methylbutane. I've got my 4 carbons, and I'll add a methyl to the 2 position. And I want the most stable, so I think I'm going to put the double bond right down the center. Okay, let's see if that works out for us. Awesome, I believe that is it. Not too bad. Yeah, so not too bad, and I hope this helps. Good luck.